Anyways, my name is Alex Bleiskin. I'm the Chief Technology Officer of Aquabotix Technology Corporation. Quick, very brief overview about the company. We're a very small company based in Massachusetts. We're founded in 2011. I've been CTO of Aquabotix now for about a month and a half. So maybe that's my excuse for getting out of some questions there at the end. Since 2011, Aquabotix has specialized in unmanned underwater vehicles, both remote operated vehicles, as well as a hybrid remote operated and also autonomous vehicle. The Swarm Diver is now a departure from that. It's essentially a micro unmanned surface vehicle that swims along the surface and can dive. So it's kind of a hybrid. I'm probably not telling most of you anything you don't know. There are many challenges with working in shallow water environments. Beach landings, mine countermeasures, detection of EOD, UXO, especially in the surf zone, can be pretty treacherous. You're dealing with waves, obstructions, reefs. You don't want to lose an expensive unmanned vehicle there. You also don't want to send somebody into a hostile environment, for example, in the middle of the night in the surf zone. I'm from San Diego and I'm a surfer, so I definitely understand how it can be difficult to maneuver around in waves and in the reef as well. So all of those little surface vehicles you see that are converging on this boat are the Swarm Diver vehicles. We'll see the specs later. They're about 2.5 feet long. They're about 2 to 3 inches in outer diameter. So you can see these guys. There's no built-in collision avoidance algorithm right now. That's a feature we're going to implement in the future. They're very robust. They can smash into each other. They can smash into metal hulls, and this is a good graphic for that. You can throw them in, they'll pop around, they'll orient themselves using GPS and be on their way. So it's GPS localized. As I said, they operate well in the surf zone. They'll run into the bottom, they'll pop back up, and they'll swim to where they need to go to get the mission done. This was filmed out at Camp Pendleton, I think at Antex a few months ago. And we will be participating in the Naval Underwater Warfare Center, Newport, Antex in August. So there you can see them kind of smashing around in the surf and continuing on their mission. So here's the specs on the Swarm Diver. As I said, it's about 2.5 feet long. The outer diameter of that fuselage is 2.25. The overall beam is 5.1 inches. That includes the buoyancy foam there you see on the top. Both of the drive motors, it's very simple design. It only uses 2 small brushless motors at the tail there. If that video played all the way through, you would have seen how they actually dive. They essentially float through the surface about like this, kind of the orientation you see on the chart there. The GPS antenna is right in there. You can see it draws kind of a line. So it floats so that's looking up when he's at the surface. And when he dives, he goes tail down, can hit the bottom and then come back up. He can go down to a depth of 50 meters, which with a lot of the labs we've been speaking with, like Office of Naval Research, Underwater Warfare Center, that's maybe overkill for most UXO shallow water missions and EOD missions as well. It sounds like 40 feet is kind of the magic number. But for us, if it can go 40 feet, it can probably go 50 meters. So that's our spec there. We implemented essentially a pseudo kind of MNA, mobile ad hoc networking waveform. So all these guys are swimming around. They're transmitting data over 2.4 gigahertz at a rate of 1 hertz. It's a pretty low throughput waveform, but it seems to be sufficient for the capabilities that we've implemented thus far, which are basic temperature, pressure, and in-depth detection. So as it is right now out of the box, the Swarm Diver is prepared to complete a beach survey, hit the bottom, see where it is, see what it looks like, and come back up. There's some spare room in the nose right now, right around where that number plate is. There's a couple inches to play with there. We've been evaluating integrating kind of more high horsepower processing units, NVIDIA chips. We think this is a good fit for artificial intelligence. Of course, it lends itself well to neural networks, where you're able to stitch together, sparse data nodes and stitch it all together and get artificial intelligence imaging and detection of EOD and UXO. And these are all things we've been talking about with kind of external parties and labs, and we're hoping to integrate a sensor package soon. So the benefits we see here is, of course, the swarm. I mean, if you're doing a beach survey or a EOD or a UXO mission, what are your options? As I said in the beginning, I'm kind of new to this. So to me, maybe your first option would be sending a diver, which is pretty dangerous depending on where you are, hostile environment, waves, middle of the night. So what do we do? What's the next extension from that? I come from a counter-IED, electronic warfare background, signal processing communications. So my history is electronic warfare. And what did we do for counter-IEDs? Rather than sending a guy in there, you send a robot. So this is taking on that same paradigm of removing the human from doing kind of the dirty work. And so that second option is maybe your more traditional ROV or AUV. And you can imagine the disadvantages there are, you're on your boat in the middle of the night, you have to pull up a chart, you have to use some new mission planning software, try to assemble your waypoints and upload it into this AUV that's maybe the size of a torpedo and costs, $250,000. The idea here is you set the center of this area, the natural harbor, the beach, where you want these guys to go. You can arrange your network around that. You can say, I want these things spaced, 10 meters apart, all the way down, 100 of them. It'll do that. You can implement a circle pattern. So you can kind of come up with your own topology there for your mission. They're extremely low cost. You throw them out there. They're more or less consumable. So those are the benefits to us over using, your traditional ROV or AOV, or, of course, a diver. So these applications that kind of spoke through that so far. It seems like most of the labs that we're interested are really focused on the EOD and UXO missions. Another thing we're talking about doing is counter UUV. As I said, I come from an electronic warfare background, and I was very involved in counter UAS at its inception. So that's another area that we're really looking forward to getting involved with, is counter UUV. You could use your swarm to surround a certain environment or your boat and set up a network of 100 of these guys and use acoustic sensors or whatever sensor you want to integrate to pick up hostile UUVs. And then, for other missions, you can do basic CTD, sound velocity profiling. So there's many applications. The swarm is a big enabler, and I think everybody's really trying to understand the value in it.